let's talk evaluating logarithmic expressions. Before we do that, I want to take a minute and just review a couple things about exponents and how those work, since exponents and logarithms are so closely related. Their rules are going to influence each other. So in case it's been a minute since you had to think about this. For example, let's see, if I say 5 to the third power, I'm sure this is no surprise to anybody. That's multiply 5 times itself 3 times. 5 times 5 times 5 is 125, no problem. If I write 5 to the negative 3 power, negative exponents move things to the denominator, or to the opposite side of the fraction from where they are. If I have 5 to the negative 3 power in the numerator, I can rewrite that as 5 to the positive 3 power in the denominator. Does not influence the sign out in front at all. The only thing that negative exponent does is move me to the opposite side of the fraction from where I am. So 1 over 5 to the positive 3, but I already know what that is. So 5 to the negative 3 power is 1 over 125. A fractional exponents. If I write 125 to the 1/3 power, fractional exponents are roots. So I could rewrite this as the third root, or the cube root of 125. What do I have to multiply times itself? 3 times to get 125, and that'll be 5. So 125 to the 1/3 power is 5. And then, of course, we can combine these. If I say, let's say, 25 to the negative 1/2 power, well, the negative power is going to move me to the opposite side of the fraction. So that's 1 over 25 to the positive 1/2. But 25 to the positive 1/2 power, that's the second root, or the square root. And the square root of 25, we know that one, is 5. Don't stop until you're simplified as much as possible. And there we go. So 25 to the negative 1/2 power is 1 over 5, 1/5. So just to recall those to mind, because we're going to need them when we start evaluating logarithms like this. Especially at the beginning, when logarithms aren't so familiar, a good strategy for evaluating them is to rewrite in exponential form. So I'm going to take this, say, okay, the base is 5. The power, that's what I'm looking for. The value of the logarithm is the exponent that I have to put on the base in order to get the third number. So 5 to, I don't know. That's the question. And when it's written like that, 5 to what power gives me 125? Well, I know 5 to the third power is 125. So the exponent that I need is 3. I'm going to point out here, log base 5 of 125 is the value of the exponent is 3. It is not 5 to the third. This would say log base 5 of 125 equals 125. 5 to the 125 power is not, in fact, 125. So the value of the logarithm is just the exponent that we need to put on the base. On to the next. Log base 6 of 1 over 36. And I'm going to rewrite. I'm going to write my base is 6. I can see. The exponent is the question. And I want to end up with 1 over 36. Well, I know 6 to the second power, 6 squared, not 2 to the 6th, but 6 to the 2, 6 squared, is 36. There's something that I know. And the only difference is what I want is in the denominator. Well, we know how to get something in the denominator. We're going to make its exponent negative. 6 to the negative 2 power is 1 over 36. So log base 6 of 1 over 36 is the exponent that I need to put on the 6, and that is negative 2. Log base 49 of 7. So again, 49 is the base. What power do I need to end up with 7? Well, I know a relationship between 7 and 49. I know that 7 squared is 49, but that doesn't help because here the base is 7. I need the base to be 49. So let's see. If I take a square root on both sides, or maybe you just know this, 7 is the square root of 49. But I also know I can rewrite roots as fractional powers. The square root of 49 is 49 to the 1/2 power. And there it is. There's the exponent that I need to put on 49 in order to end up with 7. So log base 49 of 7 is 1/2, because 49 to the 1/2 power, the square root of 49, is 7. If you're feeling brave, you can try the next one. I have log base 4 of 32. So I'm saying base, power, I don't know, and I want to end up with 32. Here's the problem. 4 to the second power is 16. 4 to the third power is 64. Neither of those is 32. But I also know that 2 to the fifth power is 32. So I might want to look for some kind of relationship between 4 and 2. But we do have one. I know that 2 is the square root of 4, which I could write as 4 to the 1/2 power. And if I do that, then I can rewrite my 2 to the fifth is, well, 2 is 4 to the 1/2. That says 2 to the fifth power is 32. And now we'll have to think back to another rule of exponents. If I have 4 to a power to another power, I can multiply the exponents together. So this really says 4 to the 1/2 times 5. I'm going to write it as 5/2. There's my exponent. We had to work for it. 4 to the 5/2 gives us 32. If I take the square root of 4 is 2. 2 to the fifth power is 32. And this is evaluating logarithms.